This talks about porting our large-scale data profiler, basically, to run inside a browser. So what we'll talk about is kind of a quick introduction to kind of what we do, and how big is big, really. What does that really mean? Why you would want to run things locally. A quick introduction to kind of what data quality profiling is, and then I'll talk and start to get in depth about kind of Scala.js. We'll talk about Spree, which is our Scala profiler and rule execution engine. And I'll go through all the steps that we went through, basically, in developing a user interface for big data, which is something that normally doesn't have a user interface, right? And then some ideas for future work. So I'll do a quick introduction on 6.6. We're a London-based consultancy. We have over 300 consultants. And we've won a number of awards and have a bunch of accreditations and memberships as well. A quick introduction on me, too. So I used to be an academic, so I was at the University of Southampton for about 13 years, and we used to work with kind of Oxford and MIT and W3C and the Open Data Institute, that kind of world. And then I've been at 6.6 for almost 6 years now. So our task was to basically build a data profiler and a rules engine to do data quality rules on data, basically. But it had to scale out horizontally. Specifically, it has to run over about 6.5 billion records. And these records had lots of different schemas, lots of different data formats, and they came from multiple systems. So if each record has 100 fields, then we're processing 650 billion values. And if we're running 100 rules on each value, then our output may be 65 trillion values. But kind of getting in your head how big or small that is, kind of especially with like Moore's law and kind of what we can actually do with the cloud now, like how big really is that? But research has shown that humans do find it difficult to perceive of numbers once they get to a certain level of big, right? Like 1 trillion, 10 trillion, is that a big difference? Well, yeah, kind of, right? But what that kind of means in my experience is you'll write some software that scales up to something really big, and then people will say, oh, well, can it load my spreadsheet and run on that? So if we talk about that kind of processing power, so when I was at university, this was the best supercomputer in the world, right? So it could do, depending on how you measure it, somewhere between 7 and 12 teraflops of performance, right? It's a huge room, and it costs $110 million, right? This is a MacBook Pro. It's a laptop. It's now available in black, and it does basically better performance than that computer did, right? And it just costs like $3,000, not $110 million. So actually, there's quite a lot you can do just running stuff on a laptop, really, right? With a lot of extra benefits. So you can try out features instantly, right? So you're not deploying infrastructure, waiting for it to spin up, waiting for a job to run. You just click the button, and it does stuff. And there's no additional cost to doing that, right? So if I'm going to want to demonstrate some solution to someone, and then I say, oh, well, I'm now going to have to figure out how much they're going to cost to do that demo, and I'm going to have to deploy all these things. Well, if it's just in the browser, then you don't. You can just try it, and people can try it as many times as they like, right? But there's also some kind of sort of really good security benefits there as well, right? If I've got some sensitive data on a machine, I can then, it never has to leave that machine, right? There's no actual server component to this software at all, right? So there's nothing for it to talk to. It's just all in the browser. This also means you can run it offline or on an airplane, that kind of thing, right? But of course, the scalability does kind of depend on largely the age of what that machine is, right? What kind of performance does it have? So developers tend to have better machines than like business people, for example, right? So what actually is data profiling? What am I kind of talking about? So if we think, one of the main things we do is kind of profile masking. So if we take a name like Joe Bloggs, we can apply a mask to it, where we basically take all of the letters and replace them with an A, take all the numbers, replace them with a 9. So the name Joe Bloggs goes to like right? And then we can turn that from what we call high grain to low grain, where everything that's repeated just gets folded together. So we end up with a pattern of AA, right? And then any name that's just 2 names, or any string that's just 2 words with capital letters, will always be that same pattern. So you can fold down a large data set into patterns very quickly, right? Similarly with a date, dates all end up looking like this. And if you're familiar with UK postcodes, there's really only 2 profile masks that fit basically like 90% of UK postcodes, right? So you can see all of these ones at the bottom basically fold to the same thing. And what you can do with that is basically aggregate them and then count all of the profile masks you get, right? So what we're actually looking at here is over 500,000 postcodes, but we can all look at it on a single slide, right? Because actually there's only this many patterns. So this is a bit of data from Companies House, right? It's like a known kind of dirty data source that's open and large. And what we can kind of see here is that actually those first two have a very high cardinality. There's large counts there. And then as we go down, there's kind of a cliff, they fall off, and there's this long tail. It's like a power law type of distribution, right? And you often see this. So what it generally means is those ones at the bottom with very few occurrences are probably problematic, and that might be where you want to look, right? And using the same technique and framework, you can basically run rules as well. So you can say, well, I'm now going to develop rules and run those against the data set and aggregate the results. And from there, you can aggregate those to determine an overall compliance score for some data set, right? So it's a bit like running masks, only your outputs are just Boolean true and false values. So you'll have things like Joe blogs, right? Does it contain only alpha characters? Yes. Does it contain only numerics? No. Does it have no white space? That's false, it has a space, right? Is it an ISO 8601 date? No, it's not, right? And as you go down, you can kind of see the difference between Joe is that like it does have no white space. And then you can see with that date, you can say, well, some of them are false, but it is a valid ISO 8601 date, and it is today as well, right? So you can kind of put whatever logic you want in these rules, right? But of course, those kind of rules only really work on a single field, right? But actually, in reality, you want to run rules over multiple fields in a record, so that would be like a record scoped rule, or also across multiple records, right? This record needs to correlate with this record, right? So if it's like an event that's happened, someone's entered a building, and then someone's left a building, you'd expect the entry to come before the exit and that kind of thing, right? So you might want to write logic that goes at kind of a data set or even like a bundle level, right? So basically, as you expand the scope from just fields to records and data sets, the parallelizability of running those kind of things in Spark obviously kind of reduces, but actually Spark these days is very good, especially in the cloud, right? So now I'm going to talk a bit about Scala.js and kind of how we were able to take that big kind of Spark, Scala, big data jobs, and run them in the browser, right? So you're probably familiar with most of these logos. So this is Scala.js, which is what kind of cross-compiles Scala to JavaScript. You've got Lamina, which is for the user interface, Vite, which is a packager, and Scalably typed, which does some very interesting things. I'll go into detail now, right? So what Scala.js does is cross-compiles Scala to JavaScript. What that means is you get things like the compile time type safety of Scala, but in JavaScript. It also means you can do functional programming when you're doing web apps as well. It's over 10 years old at this point, and support for it across the ecosystem is really good. Everyone here is basically a Scala programmer, so you've probably heard of it and kind of understand it, right? And it also has really good integrations with a lot of UI frameworks as well. What Lamina does is it's basically a library for building user interfaces. So it's a way of basically keeping the UI state in sync with the underlying app logic. So if you're familiar with like React or Angular.js, those kinds of things, it's that kind of reactive programming, but in Scala, basically, right? And it's kind of funny at first view because you're writing Scala instead of HTML as well. So yeah, that looks clear. So what you end up doing is like, I'm writing Scala, but actually it sort of looks like HTML. Like I can see a div, I can see an href tag. It's kind of weird. But what it means, of course, is that a lot of these things are variables, right? So I can start hooking up values in the HTML with things that are happening in my logic. Lamina calls this functional reactive programming. So it has this library called Airstream, which basically does kind of value propagation stuff like React and those kind of systems do. And it provides that kind of reactive model of this has changed, therefore I'm going to propagate all these other things, right? An example of this is basically imagine if you've got kind of an input box. I want to do something when something's typed in there. And then so what you can kind of see here is you basically have these kind of Airstream variables to say, okay, when there's a change this variable, and then that gets propagated down to the other divs, right? So you don't need to kind of write the events yourself. It kind of handles all that. But it's very powerful. It just kind of means that it's very easy to like modularize what you're doing as well, and without having to have something that's very difficult to maintain. What Vite does is it's basically a kind of a Webpack system. So it basically provides all of your production assets to deploy your web app, right? And it does all the kind of good stuff like live reloading in the browser. So I edit Scala, and I do that in like IntelliJ, and then that just reloads the page as I'm coding, right? So it makes it very, very simple and very quick. There's also a kind of a fast JavaScript linker called Zinc in the background, which will live reload it almost instantly, so it doesn't have to just recompile everything. It's really well integrated at this point. And this is basically a bit like Webpack or Rollup or Parcel. If you're like a front-end dev, you probably use those as well. Scalably typed is really interesting. So it basically allows you to use JavaScript libraries inside Scala. So for example, if I want to use chart.js as the kind of example people use, well, I need to know how to call that JavaScript, right? But what Scalably typed is, it basically wraps TypeScript definitions, which already exist, and maps those into Scala, right? So what that means is any library that has a TypeScript typing definition can just be pulled straight into Scala. So you don't need to kind of like mock up the interfaces or anything yourself. It's already there. You can just pull it straight in. And actually, the support for this is very, very good. And what it means is you can basically store these libraries with like NPM, and then all the types and references kind of come in straight away. So for example, I'm going to talk a bit about Bootstrap as a web UI. And it has types, right? So its JavaScript library has these types, and you can just pull this type definition straight into Scalably typed and then code against it in Scala, right? So this means that it kind of bridges that gap between native JavaScript, which is what gets actually called in the app, and you writing something against it in Scala. So it's actually very powerful. So now I'll talk about Spree, which is our like user interface for all this. So if you're familiar with Spark, it's basically a way of executing large data jobs across multiple nodes, and then shuffling all the results down in like an efficient way, which is what we do in the cloud to do our data profiling. And normally in a normal Spark job, inputs are kind of controlled with configuration and outputs are written to disk or S3 or something, right? But if we're doing this in a web application and all the logic's running here, well, now every part of this can actually be made completely interactive, right? So what that means is there are core components of Spark jobs that you need to now make interactive. So for example, data frames and data sets, the input data, configuring the source data, selecting which rules you want to run, and then looking at the outputs and looking at the aggregated outputs, and also maybe making some interactive charts that can then show you what that kind of histogram looks like, right? So if we think about making data frames interactive, if you ever use Spark, data frames tend to look like this on the top right there. So kind of like, they normally are too big to show. They're normally kind of horribly wrapped like this, and it kind of is a bit of a mess, basically. You tend to get people with just buy wide monitors and drag their terminal really, really wide, right? But we don't need to do that if we're on the web, right? We can make something actually good. So what we could do is make something which basically has some features as well. So can we make it easy to use, easy to read, do some kind of fast filtering, dynamic ordering. It would need to handle large amounts of data, but it also needs to be lightweight, right? So if it's, we may want to have multiple data frames open on the same page, that kind of thing. And with all kind of front-end development, you need to think what the user is actually going to do with it, right? So it's all well and good saying I've given you a really interactive table, but really they might want to export it and do something else. So you've got to kind of consider those things. Now there are lots of kind of scalable table implementations in JavaScript, right? So we've got like Tabulator, there's one called hands-on table, datatable.js, these kinds of things. So these are all kind of candidates for something we could use. We've got to also kind of think about making these scalable, right? I'm not just going to dump out billions of rows onto the page, right? It's either going to be slow or it's just going to be unusable, right? So we can do a few different things. So pagination is a simple one, right? Just looping through small amounts. We could do something with infinite scrolling. So infinite scrolling is very well supported, but it sort of feels more natural than pagination, but it's kind of really well suited to like a social media type of thing where you're just kind of scrolling for the next thing. But if you're actually doing some analysis of data, you probably don't want to just keep scrolling and waiting for it to load, right? There's some actually quite interesting work which is basically rendering to canvas. So whenever people generally come up against scalability issues in JavaScript that are kind of large ones, sometimes they say, well, we can use the canvas tag, which allows you to basically plot pixels, and then use some like old school kind of techniques of writing their own table themselves, which might lessen the impact of having to deal with the DOM hierarchy, right? So actually there's a few good things to do this. So there's a thing called fin hypergrid, which is this one on the right, that's entirely drawn in the canvas, and that means you can control kind of like large scale sort of data tables if you want to. But also one thing that's important to think about as well is accessibility. So accessibility is the practice of making a website usable by as many people as possible. And the kind of definition sort of says you traditionally think of this about being people with disabilities. But also it also helps people if they've got like small devices like mobiles, or if they've got slow network connections. These sort of features enable that to kind of work more smoothly, right? And actually in this case, I ended up using Tabulator because it does have really good support for the ARIA standard. And it basically means that when I put a data frame into Tabulator, it's gonna support screen readers and things like that, make it very easy to use. Similarly, we had to kind of pick a UI framework to use. So I talked before about React. We could have used React or Angular or something like that. But because I don't need those reactive features, actually kind of what I want is just a kind of a UI framework really, with like, so I can have components and things that all work well and look good. So what we ended up using was Bootstrap. It's quick, it's easy to add new features, it's got good accessibility too, and it has those TypeScript definitions, so we can import it and kind of write against all of its kind of hooks and handlers. And if you want to, it's also got loads and loads of themes. It's been around for like 10 plus years as well, right? We've also added some kind of additional things. So one of the things that I found quite early on would be useful is to actually look at exceptions as they're thrown, because obviously if I'm running like a Scala thing, then I can look at my logs. But if I'm in a browser, then what do I do? So actually it's actually possible in JavaScript to bind to the global exception handler in JavaScript, and then just show all exceptions in like a modal, and it's kind of all the stack traces highlighted, that kind of thing. I'll do a quick demo now. So yeah, so this is what it looks like. So what we've got here is we've got a small piece of JSON data, and then we're just going to click the profiler and see what it does. So what we've got here is kind of the kind of raw output, right? So this is all of the profilers, all of the output of the profiler. And you can see here I can filter it by name and just show the names, and you can see it's got the high grain and low grain outputs, and it's got those profile masks that we talked about before. We can also look at kind of the aggregate of these, so the counts, so we can see that all three of them have got the same low grain, for example. And also there's an interactive chart, so I've integrated Chart.js here, and you can then search through which path and which rule kind of output you want to look at. What we can also do is, these are all the rules that we've ported across from our other solutions. So we can say, okay, well maybe there's, for some particular field, we might want to say that the min length has to be this, or max length, that kind of thing. What we're going to do here is basically select the one that says, is it a valid date, basically, and rerun that. So we do have some dates in this data set. So when we run it, we're expecting to see that like 2 are valid and 1 isn't. So we just filter by date, and then filter by the valid date rule, and we can see that 2 have parsed as an ISO local date, and 1's parsed as false. It's not a date, right? And then, as before, we can have a look at the aggregate outputs out of that, see all the counts. So in this case, it's kind of 2 and 1, and then also we can look at the chart, right? So we can see, okay, we've got masks are like this, and kind of rules are like this. But it's kind of, I guess, one thing to look at small data sets, but what you kind of want is something bigger, right? So we've got some sample data here. So we've got some data from kind of OpenStreetMap in London, Lithuania, and some data from Companies House as well. And then we profile this. We've now got a much bigger output, basically. So I think here we have, let's have a look. I think here we have, yeah, kind of 809 rows of just immunities. I think overall it's about 1.5 million rows. And what we can kind of see is what kind of values do we have for the type of amenity it is, and then we can see that kind of cliff fall off, right, of the actual counts of the values, right. And then we can also look at the maybe at the actual names, and here you can see that kind of histogram of the fall off, right. So that power law of names that look like just a name, like a word, that's pretty common. And as we go down, you've got all sorts of kind of stuff going on here where they look quite a lot different. And then with low grain, it kind of collapses it a bit, so there's less occurrences, but still, you can kind of see very quickly, this might be where I want to focus my data quality efforts, right? So in terms of future work, one thing that might be quite good is to do more things with different scripts. So I talked about just kind of uppercase and lowercase letters and numbers, but what if I've got Unicode with international stuff, right? I think with Unicode as well, we can go beyond what you might have done in the past. So data profiling is not like a new technique. But in the past, you might have said, oh, well, CJK is probably different to Latin, right? It's just Chinese, Japanese, and Korean. But actually, really, there's 161 scripts in Unicode, and we know all of the addresses of them, so we could quite easily fold those into the A's or have their own things if we wanted to configure it in different ways. So we can say, I really want to know of all these places in London or of all this data, how much of it is in Latin script, how much of it is in something else, right? Another thing is, once I got to this point, I kind of realized, well, I've kind of commingled my source code now. I've got some which is to do with rewriting bits of Spark to make it work in the browser, and I've got some bits which are the actual data quality profiler. So I might want to refactor that out, right? So what might be very powerful is to make it API compatible with Spark itself. So use traits to swap out Spark. So maybe instead of a Spark context, have a browser context, right? So if you've ever used AWS Glue, you might be familiar with the Glue context, same sort of thing, right? And then you can provide some examples of that, probably word count, because that's what all Spark examples are, but it works. And then we'd need to come up with a name for that, which is obviously the most difficult part. But as with Spree, you can just kind of put that into ChatGPT and it'll give you some semi-good results. There's also probably, if you wanted to do this for anything quite big, there's a lot of work on optimizing it. So the reason why Spark works so well, really, is it has a really good query planner, and it does a lot of lazy evaluation type of stuff, right? This doesn't have a query planner, but it does lazy evaluate where it can. But there's some specific high-quality ways of doing parallel execution in the browser. So things like JavaScript workers, macro tasking is kind of a technique that people use as well, and potentially running Akka. It sounds like that would be a lot, but it could work quite well. And also, Spark handles caching and partitioning in a very good way as well, so that we could do more there. We could also make it more feature complete to Spark, so it doesn't do all of the kind of aggregations and joins and filtering that Spark does, so all of this kind of stuff. But it would be interesting to support that. Another thing that's possible in the browser that's more difficult in sort of Spark is adding real-time data support. So we could easily hook into WebSockets or long polling, and then we could do things like make animated charts like this, right, and just see data on the wire coming through visually. I think that would be quite powerful for a lot of use cases. Something else that's interesting is maybe using Scala native. So instead of just going to JavaScript, we could maybe use Scala native to go into LLVM, and then use LLVM to go into WASM, which may end up being faster in the browser, perhaps. But also, we could then also run it natively, right? We could just do what Scala native does and run this in Intel or ARM or something. That could be quite interesting to try out. If you want to try it yourself, you can. So because there's no server component, it's just hosted on GitHub pages, right? So if you go to dataquality.github.io, that's where I did my demo from. So it's just that's perfect for you to try out. So yeah, if you're interested in this, I'd encourage you to have a look at that. And yeah, that's the end. So thank you very much.